My name's Harriet. I hack your AI, so the bad guys can't. Okay, welcome to our first episode of this new behind the scenes series. Like I said in the intro, the point of this is not to leave you experts in the topic of today, but the point is to give you a little glimpse under the hood of the topic so that you don't necessarily need to be able to do it yourself, but you can have really robust conversations with people who do. And the topic of today is data science. So I think this is a really important topic to think about from an AI security perspective, because you could say that I've been working in AI for the last 10 years, but it's only very recently that this field was actually referred to as AI. And it was only last year that AI was defined for the first time by ISO in a quasi-technical way at all. But I'm going to get to that later. So back when I started working in AI, the field was called data science. And basically data science is the field of applying the scientific method, which is all about hypotheses, experimentation, and validating those hypotheses to try and get results and insights, but applying that to data. And data science can be applied in so many different industries. For example, this example here from the Wikipedia article is from an astronomy example. Data science is really important in astronomy because they have so much data that you need to analyze and try and glean insight from. But in every business, data science is really important because there's always some challenge that your organization, your company, your industry is looking to solve. And with all the data you can collect, you can start to ask questions about the challenges that you have and try and validate or disprove some of the hypotheses. Technically, in the scientific method, you wouldn't validate a hypothesis, you would only disprove a hypothesis. So if we think about data science and how it relates to artificial intelligence, a really good way of thinking about data science and how it fits in with other buzzwords like AI and machine learning is by looking at this data science process. I quite like this diagram because these are all the really important parts of the data science lifecycle. There's collection of data, there's cleaning the data, you do some exploratory data analysis, you build a model, and then you deploy the model. And within all of these different areas, you also have different roles that would be fairly niche to some of these steps. So data engineers would focus on collection and cleaning of data. Data analysts would spread across cleaning and the exploratory data analysis. And then machine learning engineers would build and deploy the model. And data scientists sort of sit across this all. When we're thinking about how this applies to artificial intelligence, as I've talked about in the intro and remastered series, machine learning can be considered a subset of artificial intelligence, but a really important subset. Without having some kind of model, you couldn't really call a system artificial intelligence. If you think about AI as a goal, and as a technology being made up of many different technologies, for example, machine learning models, simple algorithms, automation. Without the model part, you couldn't really call just an automated system AI, although of course some people do. So what does this mean in terms of the data scientist process and how it relates to AI and AI security? Well, here's a little demo. I already did this one in the intro series, but the whole point of the remastered series is that you don't necessarily need to go and rewatch the intro series. So here is a little example of how to build an AI. And I say AI, but basically we're going to follow the data science process to build a machine learning model. And we're going to go through all of those 5 steps, albeit briefly. And maybe not practically, like I'm not going to deploy this model, but I would then talk about how you're going to deploy it. So in this example, we're going to identify handwritten numbers using a convolutional neural network, which is a kind of machine learning model based on the human brain. And we want it to be able to predict handwritten letters. So this training data I'm using is referred to as a sort of benchmark data set because so many different models use it, and it's called MNIST. And I'm just going to Google this and you can see just how many examples of models are built using MNIST. It even has its own Wikipedia page. And it has a little snapshot of what a lot of the data looks like. These are some sample images, and it's a very popular data set because so many people do tend to use it, and so it's easy to compare your model performance to other people's models. So that's it here. So I'm going to go through this code and sort of give you a peek under the hood into how a data scientist would build a machine learning model. So here we're importing some important packages. TensorFlow holds a lot of information about models and layers, and Matplotlib is a way of plotting things in Python, also very important. So those have downloaded. Here I'm actually going to import the data set from TensorFlow. It already has a bunch of data sets available, so I can just download it in one line. And also in this line, I'm able to split it into training and testing data. The reason we want to do this is because ideally our model is very good at giving an accurate prediction for new information it sees. So we need to be able to train it on a lot of data, but then we also need to, present it with information it hasn't seen before to validate that it can actually predict what it is accurately. So there we go, we've downloaded all of that information. This basically refers to the shape. So we've got 60,000 entries and they're 28 by 28 pixels. So let's have a look at a random image. You could already see it sort of here, but yep, this is a number 8 that we have in the data set. So here, so you could consider that sort of the data collection process. And if we're really thinking about data collection, one place that data scientists will often go to if they are learning or playing around or, want to do a fun project and they don't have data that they're using from their organization, they will often go to Kaggle. Like Kaggle says, it's the largest AI and ML community, which is, pretty true. There's lots of things that are available here. There's lots of open source data sets. Here it says over 300,000 data sets that data scientists can access. Over 1,000 notebooks. So like this notebook that I'm coding in here, there's lots of other pre-made notebooks so that people can learn. And over 2,000 models, which is amazing. Here are some examples. There's data from Fitbit, International Football Results Archive, which is like an academic pre-publication database. From the Russia-Ukraine war, all of these notebooks that show you how to build a model. Models you can pre-import, so big ones from Google, Meta, Keras, which is also part of TensorFlow, Meta, and it has lots of case studies. More importantly, it has lots of competition, so you can actually win a lot of money and jobs by producing really good responses to these competitions. So usually, if you produce the model with the highest accuracy, you'll win, but the model also has to be, safe, reliable, robust, all those kinds of things to be able to win. So that's Kaggle. So that is one place we could go to collect data, but here we've just sort of taken the easy route where we're just inputting that MNIST data. And here I'm going to do some data processing. So I need to be able to process all this information so that it can be read with the Keras API, as we're saying here. So we need to make sure it's in the right shape. We need to make sure it's in the right data type. So here we're changing it to a float. And we need to make sure that the RGB values are normalized. So because that's the red, green, blue value of the pixel, we need to make sure that it is a value between 0 and 256. So let's run that, it's pretty quick. And now what we're going to do is start building the model. If we were doing a different project, that data engineering would take a lot longer. There can be so many things that are wrong with the data that we need to verify. Things like bias, things like, just the correct data to begin with. I'm going to cover that in a separate episode, but for now, here's just a really high-level overview. We also haven't done a lot of exploratory data analysis because we already know what this is, but there's going to be another episode on that too, because it is actually quite important. What I want you to note here is that we're now building this model. So we've chosen a sequential model, and we're literally adding all of the different layers in our model. So as a data scientist, I have total control. I guess if I were working in an organization, it's my, I'd still have to answer to a manager and all that kind of stuff. But the data scientist has a lot of control over the model and what kinds of layers it uses. Here, convolutional 2D is a kind of layer. We need to specify sort of the kernel size, which is like how much information it's learning in that layer and retaining. And the input size, so that's 28 because the images are 28 by 28 pixels. And then we have to do a similar process for each of these layers. And there's quite a lot of theory and best practice that goes behind which layers to add and when. However, in practice, for a data scientist, it can also often be a bit of, this seems right, this seems accurate, let's play around, bit of trial and error. But there is quite a lot of theory that goes into it too. So here we're going to build the model. And now we're going to go and compile it. So just like you have to compile any program, you also have to compile a model. And then we need to fit the model, which is basically the training process. And it's crazy that we can only do this in one line of code, right? It's very powerful. Here I've just specified, what data I'm using. This is the training data. Epochs is sort of the number of iterations or learning stages. Typically you would do more, but it's already going to take a little while. So what I'm going to do while I wait for it is to head back over here and show you some other cool things. So like I mentioned, artificial intelligence was only defined for the first time last year by ISO, which is the International Standards Organization. And this was kind of a big deal because throughout my entire career, I always referred to myself as a data scientist, and I built machine learning models. I never talked about AI. AI was this very ephemeral goal. It didn't really refer to any specific technology. It was what our business people would put on PowerPoint slides to market to, customers and clients, but it didn't really mean anything in a practical way as a data science practitioner. And so when ISO defined it last year, this made me really have to reconsider the kind of language I'm using. And because they defined it in a fairly technical way, I'm now understanding that, need to embrace the term artificial intelligence at the very least because most people who are not data scientists understand artificial intelligence as the word that kind of refers to all things models and data science. So if anything, it's more inclusive. But the thing about the way they defined it is that they defined it as this. So they define it as a technical and scientific field devoted to the engineered system that generates outputs such as content, forecasts, recommendations, or decisions for a given set of human-defined objectives. Now, when I speak to most people about artificial intelligence, the first thing they think of is like Skynet. They imagine this super intelligence. Clearly, the actual technical definition is pretty far off. It's a system that can do something, like it generates outputs, it finds patterns, it makes predictions. We can even go to the specification here where it actually talks about artificial intelligence. You have to pay for it, which is pretty classic, but you can actually read the sample, which is fortunately has all the information that I need to know. It's fairly long, so I'm going to skip down to where it talks about artificial intelligence down here where it defines it. So here we go. So there it is again, that system that generates outputs, etc., etc. But here it specifies what's really important, and that is that the engineered system can use various techniques and approaches related to AI to develop a model to represent data, knowledge, processes, etc. So when we think about artificial intelligence, we often, like I said, consider it an umbrella that could include automation, algorithms, and machine learning models. But without the model, it's not really artificial intelligence. So with that in mind, let's head back over to our model and see how it's doing. And it's still training, but it's almost there. So let me waffle for a moment while we wait for it to finish. Now, the point of this activity is not to bamboozle you with code, but the point is to show you that just in this very small notebook, I can build a model. And as a data scientist, you wouldn't build a model this quickly for a real problem. It's easy because this one's fairly predefined, and I know what I'm looking for. I've done the demo a lot. But if you're looking for something new, you're looking for new insights in your business, the way that you approach the data science process very much has to be based on, disproving specific hypotheses that you might have in mind. Okay, it's finished training, so now we're going to evaluate it. Okay, so what this is telling us is the loss is like the error, so how inaccurate it is, and then this is obviously the accuracy, and so these total to 1 or 100%. And so basically this model is 99% accurate. And the way we know that is because we're now using the test data. So the model hasn't already been exposed to this test data. So we can use it to verify how accurate the model actually is on data it hasn't seen before. And it's very accurate. And if we look at this summary, we can see all of the different layers, we can see the output shape and the number of parameters. So there's many, many parameters. And this is why neural networks are often referred to as black box. You know, they're fairly uninterpretable. There are ways that you can interpret it, of course, and that's going to be a subject of another episode as well. But here we are just displaying a random number, 4444, and we're getting it to predict what it is, and it's 9, and that's correct. So our model is pretty good. But that's how you can build a model in maybe 10-ish minutes with a lot of talking. And the reason that that works, I'm going to head over here to Brilliant, brilliant.org. I'm pretty sure I can show this. This is just their free version. It's not like I'm showing the paid version to, for free. But I recommend you head over here because they have a lot of really cool visuals in artificial intelligence and machine learning. And if you want to sponsor me, Brilliant, that would be great because I like showing your visuals to many people. But basically the way it works is that here is a neural network. They've called it an ANN for artificial neural network. And it's got 50 neurons in 2 layers. So in the example over here, I have all of these layers, so way more than 2 layers. And this is basically the number of neurons in each. So what it looks like behind the hood is if I'm writing a number, that's sort of the activations of all the different neurons. And up here, you can see that they're leading towards a prediction. That there's lots of computations going on in each of these neurons that is causing it to, predict the most likely number. And so at this point, it predicts that it's 7. But what I'm going to do is I'm going to finish and draw the 2. And now you can see that it most likely predicts it's a 2. And you can test that with all sorts of numbers. Like I said, it's not very interpretable what all these neurons are referring to, but we're going to discuss that in another activity. So there you go. That's a really quick foray into the data science process, talking about the intersection with machine learning and artificial intelligence. And now you can see what a data scientist does in sort of 15 minutes. So I hope you found that interesting. Future episodes are going to go into all of these stages in more detail and explain why they're really important, but also how they contribute to, the potential attack surface from an AI security perspective. How all of these different layers and the different ways that they're configured and built, and, the impact of the data set and how the model is deployed, how that can all contribute to the potential vulnerabilities in an AI system. So if you have any other questions about this activity or any of the future ones, please comment down below and I'll make sure to address them in future episodes. But please do subscribe. That's a really, that's a nice and free way that you can help me out, help me grow my channel and spread this to more people. And like this video, and I'll see you in the next one.